Now we solve one numerical example, means we try to find out a solution of a system of a linear equation by Cholesky's method. So in order to save the time, here already we write a problem. So what is the problem? Solve the following system of equation: x1 plus 2x2 plus 3x3 equal 5, 2x1 plus 8x2 plus 22x3 equal 6, 3x1 plus 22x2 plus 82x3 equal minus 10 by Cholesky's method. By Cholesky method. Cholesky method. Now, how we find the solution? First of all, we write the given system of a linear equation in a matrix form. So, now the matrix form of a system of a linear equation, the matrix form of given system of a linear equation, given system of a linear equation, linear equation is as follows. So what is the, first we write a what? First we write the coefficient of a x1. So coefficient of a x1 is a 1, 2, 3. So this one is a 1, 2, 3. The coefficient of a x2 is a 2, 8, 22. Coefficient of a x3 is a what? 3, 22 and 82. Then we write a vector of unknowns x1, x2 and x3. This one is a vector of unknowns. And what is the value of a right hand side? The value of a right hand side is a 5, 6, minus 10. So if we denote this matrix by the A, and this one is a vector x and this one is a capital B, then this become Ax equal B. Now, in order to apply the Cholesky's method as we discussed earlier, A must be a symmetric matrix and positive definite. So let us check the property of A. Either A is a positive definite or not, either A is a symmetric or not. So now in the next page we write a what? We write the matrix A. Now A equal, here we write a matrix A. The values of a matrix A is a 1, 2, 3, 1, 2, 3. This one is a 1, 2, 3, 2, 3, 8, 22, 22 and next one is a 82. So first of all we check the given matrix is a symmetric or not. So as we know that a matrix is a symmetric matrix if matrix A is symmetric, if Aij equal Aj Ji. What is the meaning of this one? For all Ij, for all I and j, for all I and j. What is the meaning of this one? Means A12 equal, if I is a 1, j is a 2, then A12 equal A21. So in other word, you may also say that if a transpose of any matrix is equal to the matrix itself, then that matrix is a symmetric matrix. So either you check this property or you write the transpose of this one, then the transpose of this matrix is a similar to the matrix A. So here the matrix is a what? The transpose of this matrix is a itself a matrix A. Since A transpose equal A here, then the matrix is a what? Matrix is a symmetric matrix. And also you may, if examine the values of a A12, A11 equal A11, obviously diagonal elements. And if we talk about the A12, here this one is a A12, then this one is equal to the A21. Similarly, A13 equal to the A13, means first row equal to the first column, second row equal to the second column, and third row equal to the third column. So either we check this property or we write a transpose of any matrix. If transpose of that matrix is a matrix itself, then we say that the matrix is a symmetric matrix. Since A transpose equal A here, this property satisfies for this matrix. Thus A is symmetric matrix. A is symmetric matrix. Symmetric matrix. Symmetric matrix. Now, A is a positive definite or not. So, a matrix is said to be a positive definite if the values of a principal minor is greater than 0. If the values of a principal minor is greater than 0. So, what is the values of a principal minor here? So, principal minor means what is the principal minor? First principal minor order of a 1, principal minor of order 1 means A1 equal determinant of a 1, determinant of a 1. A2 is a determinant of a 1 to 2, 8, 2, 8. A3 with a determinant of a 1, 2, 3, 2, 8, 22, and 3, 22, and 82. If the value of a principal minor is greater than 0, then matrix A is said to be a positive definite. So here what is the value of a A1? This one equal 1 and this one is greater than 0. What is the value for this one? The value for this one is 8 minus 4, this one equal 4 and this one is also greater than 0. And if we try to find out the value of this one become 1 into 8 into 82, 8 into 82, 82 minus 22 into 22, 22 into 22, 22, and similarly this one minus we write a 2 and inside this become 2 into 82, 2 into 82 minus 3 into 22, 3 into 22, 22, then plus 3 means we find the determinant of this one 3, this become 2 into 22 minus 3 into 8. So if we simplify this one, then this one is also a greater than 0. This one is also a greater than 0. We have already calculated the value of this one. The value of this one is a greater than 0. This means the principal minor of order 1, principal minor of order 2, principal minor of order 3 is a greater than 0. Thus we conclude that the matrix A is a positive definite also. So how we find the how we decide the matrix A is a positive definite? Once again, find the determinant of this one, then determinant of this one, 2 cross 2, then determinant of a whole matrix, whole matrix. So this one is a way how we decide, this one is a one way how we decide a matrix is a positive definite or not. And another way how we decide a matrix is a positive definite or not, if the values of all diagonal element is a greater than 0, not diagonal elements, sorry, if a values of a eigenvalue of that matrix, if eigenvalue of that matrix is a greater than 0, then also we can say that the matrix is a positive definite. So there are different ways to show that a matrix is a positive definite or not, one of the easiest ways is find the principal minor of all the order of a matrix A. If that one is a greater than 0, then we say that matrix is a positive definite. So here principal minor is greater than 0, so matrix is a positive definite. Thus this implies that A is positive definite. A is positive definite. Positive definite. Definite. Now if A is a symmetric matrix and A is a positive definite, then we able to apply the Cholesky's method. Otherwise we unable to apply the Cholesky's method because we unable to decompose the A as a L into L transpose. If any one property does not satisfy, then we are unable to decompose the A as a L lower triangular matrix into transpose of a lower triangular matrix, or upper triangular matrix into transpose of a upper triangular matrix. Now A is a symmetric and positive definite. Now A is symmetric, and positive definite, and positive definite. If A is a symmetric and positive definite, then A can be decomposed at A equal LL transpose. LL transpose. Now we write here. Now again let L is this one, L11 0 0, L21 L22 0, L31 L32 and L33. Now we try to find out the values of L. Once we find the values of L, then we are able to write the LL transpose. So this one is a L. Now A is a what? Now A is a, here we write matrix A. Let L is a this, then L transpose, obviously L transpose up, you can write L transpose row, first row become first column, second row become second column, and third row become third column. Now we write matrix A here in order to find out the values of a lower triangular matrix. So A is a what? 1 2 3, 1 2 3, this one is a 8 22 22, and this one is a 82. Once we verify this one is a matrix or not, 1 2 3 1 2 3 8 22 22 82, 22 and 82. So this one is a matrix A. So we can write this one equal L, means L11 0 0, L21 L22 and 0, L31 L32 and L33. This one into L transpose. Into L transpose, here we write L11 L21 L31, and second row this becomes 0, L22 L32, and this one is a again second row, third row 0 0, and this one is a L33. So if we multiply these two matrices L and L transpose, what is the value? The value become here first row by the first column. First row, this one, first row by the first column, then first row by the second column, first row by the third column, then we find the values of values after multiplication of L and L transpose. So what is the value of a first element of after multiplication? This one is a L11 square. L11 square, first row, first column. First row, second column, then second element become L11 into L21. First row, third column, this become L11 L31. Now second row first column, then this become L11, L21. Second row second column, this one is a L21 square plus L22 square, L22 squares. And second row third column, this become L21, L31 plus L22, L32. Similarly, third row first column, then this become L31, L11, and third row second column, then this become L21, L31 plus L22, L32. And third row third column, then this become L31 square plus L32 square plus L33 square. And this one equal to what? This one equal 1, 2, 1, 1, 2, 3, 2, 3, 8, 22, 22, and this one is 82. Now we compare the matrix of a left hand side and matrix of a right hand side. So element by element comparison. So what is the value of a L11 square? The value of a L11 square is a what? The value of a L11 square is a 1. Comparing this one, then we find what? Here we write a L11 square equal what? 1. So what is the value of a L11? L11 equal 1. Here we consider the positive root. Here we do not consider the negative root, because here L11 square equal 1, then obviously it's have a two value plus 1 and minus 1. Here we consider the plus 1, you may also consider the minus 1, but there is a chance of a chance of a propagation of a error is larger in comparison of if we take a positive value. But in some cases we also able to find out the value of a the solution of a system of a linear equation if we consider the negative value also, but here only we consider the positive root. So once again I repeat this statement, because this one is a very important. Always we consider a positive root. So L11 equal 1. So if we compare the first element, if we compare the second element, then L11, L21 is a 1 or 2 second elements, and here if we write L11, L11, L21 equal what? 2. Then what is the value of L22? L22 become what? 2 by L1, 2 by L11, this one equal what? 2. Similarly, we able to find out what? L31. L31 equal what? L31 equal here L11 is a 1, L21 is a L21 is a 2. Similarly, if we write here, because if we write in a next page, then again we need to these two matrix to find out the values of a element of a lower triangular matrix. So here we try to calculate on a right hand side of this page only. So L21 is a 2, and similarly L11, L31 equal 3, then L31 equal 3 by L11, this one is a 3 by 1, and this one equal 3. Similarly, there is no need to calculate the value of L21 again, because if we closely observe this matrix is also a symmetric matrix. So we move on here. There is no need to compare this one, because already we calculated the value of this one L11, 21, L21, L11, this one. So we calculated the value from here L21, from here we calculated the value of L31. So there is no need to comparing this element with the element of a matrix of a left hand side. So we compare again this element L21 square plus L22 square, this one equal 8, this one equal 8, and we have already calculated the value of L21. The value of L2n is a 2. So this becomes 2 to the 4. So 2 to the 4 plus L22 square equal 8. So L22 square equal 4. Again we only consider the positive root. So the value of L22 is a 2. Similarly, we compare this one L21, L31 plus L22, L32 equal to what? Equal to 22. So this one equal 22. Now we put the value of L21, L2n is a 2, L31 is a 3 plus L22 is a 2, L32 is an unknown, this one is a 22. So if we simplify this one, so 3 2 is 6, so 6 plus 2 into L32 equal 22. So if we simplify this one, so this become 16 means L32 with a 8. So in this manner we calculate all the values L11, L21, L22, L31, L32, L33. So in the next phase we already write the values of all values L11, L21, L22, L31, L32 and L33. Here we calculated the value of L32. L32 is obviously this one equal, L32 equal 8. Similarly, we compare L square 31 plus L square 32, L33 square by 82 and putting the value of L31, L32, then be able to find out the value of L33, and this one is equal to what? This one equal to the 3. Now, once we find all the element of a lower triangular matrix, then what is the matrix L? Now matrix L become, now L equal what? L equal L11. L11 with a 1, 0, 0, L21 with a 2, and L22 with a 2, and this one is a 0, and this one is a 3, and obviously this one is a L31, this one is a L31, L32 with a 8, and L33 with a 3. So this one is a matrix L. Now obviously what is a L transpose? There is no need to write a L transpose because we are able to write a L transpose. This one is a very simple process. Now apply the Cholesky's method. Now let here I think already we write A equal L transpose. Okay, sorry, we have not write this one. So here let A equal L into L transpose. A equal L transpose. This will surely satisfy because A is a symmetric and positive definite. So A equal L transpose, then Ax equal B become what? Become as what? In place of A, we write a L transpose, this become B. Now again we assume that what? Again let L transpose X equal Y, where Y equal Y1, Y2 and Y3. Y1, Y2 and Y3. Now if L transpose x equal y, then putting the value of L transpose x equal y in this equation. Suppose this one is equation number, this one is equation number 1, this one is equation number 2, and this one is equation number 3. Now from third equation, second become what? Second become Ly equal b. This one is equation number 4. Now first we solve, as earlier we discussed, in a Cholesky's method, first of all we solve the equation number 4, Ly equal to v, in order to find out the values of a y. Once we find the values of a y, then we solve L transpose x equal y in order to find out the original unknown. So now we try to solve Ly equal to b. Now we solve Ly equal b. So L is a what? This one is a 1, 2, 3, 0, 0, 2, 0. This one is a 3, this one is a 8. This one is a value of a L. Once we verify this one is a value of this one, 1, 2, 3, 1, 2, 3, 8. And what is the value of a y? Y is a y1, y2, and y3. And now what is the value of a b? In a starting, there is a values of a b. So what is the value of a b? 5, 6, and minus 10. 5, 6, and minus 10. So 5, 6, and minus 10. Now we perform a forward substitution in order to find out the values of a y1, y2, and y3. Now we perform the forward substitution. Now in order to find out the values of a y1, y2, here we perform the forward substitution. In, suppose this one is equation number what? This one is equation number 5. This one is equation number 5. In equation 5. Then row by column. So what is the value of a y1? y1 equal 5. What is the value of a y2? Second row and this vector. Then this become 2 into y1 plus 2 into y2 equal what? 6. And we have already calculated the value of a y1. Now putting the value of a y1 here, then this become 2 into 5 plus 2y2 equals 6. Then this implies that 2y2 equal 6 minus 10 and y2 equal minus 4 by 2. This one equal minus 2. So 2 into 5, 10, 6 minus 10, this become minus 4, y2 become minus 2. Similarly, third row at this vector, then this become what? 3 into y1 plus 8 into y2 plus 3 into y3 equal what? Minus 10. Now we put the values of a y1. y1 is a 3 into 5 plus 8 into minus 2 plus 3 into y3 equal minus 10. Then this become 15. This become minus 16 plus 3y3 equal minus 10. Then 3y3 become what? Minus 10, and this become minus 1 plus 1, this become minus 9. Then y3 become what? y3 become minus 3. So once we find the value of a y1, y2 and y3, then we solve. Now we solve what? Equation number 4. Equation number 3. Now we solve equation 3. Now we solve L transpose x equal y. L transpose x equal y. So what is the value of L transpose? If this one is a L, then first row become first column, this become 1, 2, 3, second row become second column. So second column becomes second row 0, 2, 8, and third row becomes 0, 0, 3. And what is the value of x? X is a what? Vector of unknown. So this become what? This become x1, x2, and x3. This one equal what? This one equal to the values of a y1, y2, and y3. So what is the value of a y1? Y1 is a 5, y2 is a -2, and y3 is a -3. 5, -2, and -3. Once we verify this one is a values of a y1, y2, and y3, obviously. So this one is a y1, y2, and y3. Now we perform the backward substitution. Now if this one is equation number 6, now by backward substitution, now we perform the backward substitution. Here we write a backward substitution, or you may also write here. Now we perform the backward substitution. Backward substitution. Backward substitution means last row at this column. So last row, this one by this vector x1, x2, 0 into x1, 0, 0 into x2, 0, 3 into x3. So 3 into x3, this one equal what? This one equal -3. 3 into x3 equal -3. So what is the value of x3? x3 become -3 by 3, this one equal -1. This one equal -1. Now second row and this vector, then this become what? Then this become, again here we write, because if we write in a next page, then there is a need to write this equation again. So here second row and this vector, then this becomes 0 into x1 plus 2 into x2 plus 8 into x3, this one equal -2. We have a value of x3, x3 is a -1. So 2 into x2 plus 8 into -1, this one equal -2. So what is the value of 2x2? 2x2 become what? -2 plus 8, this becomes 6. This implies that what is the value of x2? The value of x2 become what? 2x2 equals 6. Then x2 become what? 6 by 2, this become 3. So what is the value of x2? x2 become 3. Now again here we find the value of what? We multiply first row by the vector x, then this become what? This become x1 plus 2x2 plus 3x3 equal what? Equal 5. Equal 5. Now we have a value of x3 and x2. x3 equal -1, x2 equal 3. So here we put the value of x2 and x3, 2 into x2. x2 is a what? x2 is a 3. 3 plus 3 into, what is the value of x3? x3 is a -1. This one equal what? This one equal 5. So if we simplify this one, then this become x1 plus 6 minus 3. This one equal 5. So x1 plus 3 equal 5. x1 equal what? x1 equal 5 minus 3. This one equal 2. x1 equal 2. So what is the answer? Answer become x1 equal 2, x2 equal 3, and x3 equal -1. Once we verify this one, x1 equal 2, x2 equal 3, and x3 equal -1. 2, 3, and -1. So this one is the answer, 2, 3, and -1s. So once we verify this one is the answer or not. So this one is the answer. So what is the summary? How we solve any system of a linear equation by the Cholesky method? First of all, we write a given system of a linear equation in a matrix form. Once we write in a matrix form, then we check the property of A. A is a symmetric or not. A is a positive definite or not. If A is a symmetric and positive definite, then only we able to apply the Cholesky method. Why? because only we able to decompose this A as a L into L transpose. If A is not a symmetric, A is not a positive definite, if any one property does not satisfy or both property does not satisfy, then we cannot decompose the A as L into L transpose. So once we verify this property, if this property satisfy, then we apply the Cholesky method and write A as L into L transpose. Then we write A equal L into L transpose, multiply L and L transpose, compare element by element of left hand side and right hand side. Then we find the values of L11, L21, L31, L2, L11, L21, L31, L22, L32 and L33 by comparing, means after multiplication of L and L transpose with the matrix coefficient matrix A. So once we find all the unknown of a lower triangular matrix, that's here we write, means L11, L21, L22, L31, L32, L33. Once we find the values of L, then as we know that if A is a positive definite and symmetric, then A can be decomposed at A equal L into L transpose. So we put the values of A equal L into L transpose in a given system of a linear equation in a matrix form. Then again we assume that L transpose X V equal L transpose X equal what? L transpose X equal Y. If we put L transpose X equal Y, then what will happen? Ly become V. So here Y is a what? Y is an unknown vector, and how many number of elements? Number of element equal to the number of equations. So first of all we solve Ly equal V. Ly equal V in order to find out the values of a y1, y2 and y3. In order to find out the values of a y1, y2 and y3, we perform the backward substitution. Then again we put the values of a y in this equation L transpose X equal to Y in order to find out a value of a original unknown. So this one is how we solve any numerical problem with the help of a Cholesky method unknown. So this one is all about this lecture. Thank you joining my lectures. Thank you watching my videos. Thank you.